I am on page 50 in the textbook, and we are looking at the definition of a proportion. So, one thing about this textbook that I really like a lot is that they give you the formal way of writing these. The downside of that is that it looks scary if you don't know what it's saying. So I want to take the time and make sure that we talk about these. But on page 50 at the very top, it says a proportion is a mathematical statement that two ratios are equivalent. A over B equals C over D. So I'm going to simplify that and say that a proportion is just two equal ratios. Now, I want you to just put this aside for the moment. We're going to bring it down. I'll tell you what, I'm just going to take it away for the moment. So let's focus on this just common sense wise, and then we'll apply that scary looking thing. So remember in the last video, we had a ratio that looked like this. You remember we simplified it by 2. We did it on the calculator also, but we said 2 into 10 is 5, 2 into 28 is 14. We simplified the ratio. Okay, let me take this away, and what you have there is a proportion. You have two ratios that are mathematically equivalent. Let me give you some others. Let's take 5/15 and simplify that. So we're going to divide top and bottom by 5 to get 1/3. So that's two equal ratios. That means that is a proportion. What about 22 over 24? You can plug that in your calculator, or you can divide by 2's, and you get 11 over 12. That is a proportion. What about 8 over 2? So you would say 2 into 8 is 4, and 2 into 2 is 1. Again, that is a proportion. So here's that pattern again of A over B equals C over D. It is simply saying that two fractions are equal. That's all it's saying. That AB equals CD if they are a proportion. Okay, I want to show you something that is very interesting about proportions. So let's zoom in right here. Focus just on this for the moment. I want you to, I would suggest using a different color of pen or pencil, but you can do it either way. I want you to draw this around the 28 and the 5. So I'm taking the denominator of this fraction and the numerator of that fraction, and I'm putting them in a ring. Now, to me, that ring looks like a peanut, so I'm going to call that a peanut just for reference. The true name for this process I will tell you in just a minute, but let's think just a minute about a peanut. You always will multiply a peanut. If the numbers are in the peanut together, they're going to get multiplied. So 28 times 5, and I'm going to use my calculator because I don't do math in my head very well. If I have dyslexia, and so that makes a difference. All right, let's do the other way. So here's a peanut with a 10 and a 14, and we always do what with peanuts? You always multiply them. Okay, so we're going to have 10 times 14 is 140. Now, if you get an equal number right here, you have a proportion. These are called cross products instead of peanuts. This process is called cross multiplying. If cross products are equal, you have a proportion. Okay, so let's try the next one. Let's look at 15 times 1. So here's going to be the first peanut. So you get 15 times 1 is 15. And then the other peanut is 5 times 3. You always multiply peanuts. The cross products are equal. This is a proportion. This is a big one. We have 22 times 12. And I'll use my calculator. That's 264. Don't hesitate to use the calculator. I would rather you use the calculator than make a mistake on the math. 24 times 11 is 264. So even though that's a huge set of numbers, that is a proportion. And then this one, we can probably do this one in our heads. If not, use your calculator. 8 times 1 is 8. And then 4 times 2 is 8. Cross products are equal. You do have a proportion. So on page 50 at example 1, it tells us to determine whether the ratios 4/6 and 2/3 form a proportion. So you will set up the ratios and multiply them. And I get questions a lot. Can I do this one first? And you absolutely can. That's 12. And then this one, sorry, I hit erase for some reason. 4 times 3 is 12. So yes, this is a proportion because cross products, in other words, the peanuts, and I'm writing peanuts, cross products are equal. Your college professors will call these cross products. I call them peanuts. When you see the peanut, you know you're testing a proportion. If you see the word proportion in a word problem, draw the peanuts. Okay. All right. The next example on this page is example 2. And it says, suppose you can buy 8 paintbrushes for $10. How many paintbrushes can you buy for $25? So what are we comparing? The two quantities are dollars and paintbrushes. So it says that you can buy 8 paintbrushes for $10. So how many can you buy for $25? So 25 is dollars. It needs to go on the dollars row. All of this is dollars. All of this will be brushes. And we are looking for the number of brushes that we can buy. So I want to draw a peanut. So I have $25 times 8. You always multiply the peanut, and that is 200. Now when I go to draw a peanut right here, it's not a full peanut, right? There's nothing here for me to multiply. That's what we're looking for. So we're not going to draw a peanut there because there's nothing there to multiply. We're going to take the 200 that we got from that last multiplying, and we're going to divide it by the $10. So 200 divided by $10 is 20. And that is the missing piece of that peanut. 20 brushes for $25. Okay. So this is called, let's put the labels on it. Example 1 was test a proportion. Example 2 is to solve a proportion. Now, when I was teaching this in a classroom, I would stop right here and have my students to solve about 100 proportions, just to let them get into the habit of how to do that. So if you're not feeling real good about this at this point, I would stop the video, ask your instructor to give you some examples to practice on. But if you are feeling pretty good about it, let's keep going and see what we have. I want to do the margin problem before I do the Think About Math set. So this is called the core skill, and it's over in the margin. And it says use ratio reasoning. Many problems can be solved by identifying key information in the problem that can be represented as ratios and then using your knowledge of ratios to solve. Here's an example. An art teacher is buying classroom supplies. 12 bottles of paint cost $38.28. How much will 36 bottles of paint cost? Well, I'm comparing dollars to what? A lot of students will say paint, and that's good. But how is the paint packaged? Is it in bags? Is it in tubs? Is it in squirt bottles? It just says that it is in bottles. So we're doing dollars and bottles. And it tells us that 12 bottles cost $38.28. Now, if it asked for a unit rate, I could simply divide there and get that answer. But it's not asking for a unit rate. It's not asking for one. It wants to know how much 36 bottles will cost. So bottles are on the bottom. Dollars are on the top. And this time, I can draw a peanut right there. So I'm going to multiply a peanut. $38.28 times 36 is huge. Don't panic. Now, I can't draw another peanut because there's not enough stuff there. It would be missing a nut in that other peanut. That's what we're looking for. So let's divide by the 12. Divided by 12 equals 114.84. And that makes sense because I'm looking for money. That would be $114.84 for 36 bottles. So again, we had to solve the proportion to get the answer there. I would like for you to stop the video and try the 2 problems under Think About Math. And once you get answers, go ahead and start the video and see how you did. So pause the video, try those 2 examples, and then we'll come back and work them. Number 1. A small auto company produces 220 vehicles in a 5-day work week. How many cars will they produce in 15 days? So we are comparing vehicles to days. The first thing I want you to check is that you wrote these words down. 220 vehicles, 5 days. We want to know how many they could produce in 15 days. So check your setup, and then you should have drawn a peanut right there. So 220 times 15 is 3,300. And then 3,300, can't draw another peanut, but we can divide by half a peanut, is 660 vehicles. Excuse me, in 15 days. And number 2. A car company pays $112.40 for 8 door handles. How much will they pay for 24 door handles? So the first thing we should be looking for is what? The words. Dollars per handles. $112.40 for 8 door handles. We want to know about 24 door handles. So the peanut will go wherever it can. We get 112.40 times 24. It's big, but don't panic, you're not finished yet. That number, just leave it on your calculator screen and hit divide by 8. And that is $337.20. So 337.2 for 24 handles. You are solving a proportion. If you didn't do well on page 50, go ahead and stop the video, talk with your teacher before you move on to page 51. But if you're ready to move to page 51, let's do that in the next video.